Alright, so we're going into 4.2 here, and 4.2 is actually going to be a real quick lesson. I'd highly advise, if you want to, go ahead and print this up. I'm not actually going to do everything in here. I'm just going to actually be doing little bits and pieces of this. It's a very short section. You're going to like the graphing of these. These are going to be our exponential functions. And an exponential function basically is any function that's going to have a base with some exponent at the top. Okay? And we're going to just be doing basic ones, and since you don't technically get to use a graphing calculator, we're going to use some basic ones, and we're not going to make you graph really weird ones, and you're going to find that the transformation of these are actually going to be pretty easy as long as you can know your transformations. Okay, so a couple things. One, okay, here's one that we call, it's base 3. It's an exponential function, and this is what we know as base 3, which means that it has a base 3. And if you plug in some values for x, notice I've got them already plugged in here. 0, remember, any exponent of 0 gives you a 1 value. Okay, and then we plug 1 in. 3 to the first is 3. 3 squared is 9. 3 cubed is 27. Those are pretty easy. And then negative 1, remember, a negative exponent brings that value down to the bottom, 1/3. Negative 2 brings that whole thing down to the bottom, so it's 1 over 3 squared, which is 1/9, and then 1 over 3 cubed, which is 1/27, which are not the biggest deals that you have to actually deal with. But if you look here, this is how this exponential graph is. And if you know the phrase grows exponentially, it starts to grow here and it goes really fast, up really fast, and grows really fast. It's called exponential growth. You guys in science have seen that before. But if you go the opposite direction and you get closer and closer, notice it's going to get closer and closer, 1/3, 1/9, 1/27, 1/81, and so forth. It's going to get closer and closer, but never gets to the 0 bottom. So that means we're going to have that nice little horizontal asymptote on these. Okay? And that's always going to also occur. Okay? The other thing about base functions is, anytime we put a 0 in, we're going to get a 1. Okay, so if you look here at base 2, and I'm going to let you see this, and again, copy it down, stop the problem, and copy it on your own paper. Okay, we're going to have, here's base 2. Notice how it's very similar. You have these same points I plugged in. Here's those fraction, and again, we're going to have another horizontal asymptote here at 0. Okay, so again, you're going to see those. And the only thing we want you to be able to do is do transformations off of these. Okay, so when we deal with these transformations, as we talk about them, you're going to be looking at a couple different things, and these are your vertical stretches and shrinks and all that other fun stuff. And the nice thing about your online stuff is they're going to give you the parent function. Okay, they're going to give you a parent function, and you're going to look and see what's happening to this. Okay, now if you remember, and there's one thing in here, if there's, this is we're not going to deal a whole lot with, but we'll talk about it here. Here's your A. Your A is going to come in front of your base number, so it has to come out here. Okay, you're going to have your C value, which is your left or right, and your D value, which is up or down. Your A is going to be your vertical shift and shrink. This B is your base. Capital B I'm going to use as your base. Okay, but if you also have a value in here, that's B might be a horizontal stretch or shrink, or your reflections. So this would be your parent function for base 2. That's just on the last page. Okay, so here's your parent function. Okay, what you're going to be asked to do is take that parent function and do certain things with it. Flip it, move it side to side, and just translate it. And it's a pretty easy move. So all you just have to do is know what your transformations are. And notice the negative right there. That negative is going to be up here. Alright, so when we talk about being up there, that's going to be those B values. So if that X is negative, this is going to be a reflection over the Y-axis, which means these points are going to flip over this line here, which means this is going to stay here. This one's going to go here. Okay, this one's going to go here. And all you have to do is figure out, okay, that's where my graph is. Simple as that. Okay? Same thing with this one. Now, they write it a little bit different. 1 minus this. Okay? Which means this is what it would also look like if you put it in the same order. Okay? which means if you looked at our transformations, hopefully you know that that's going to be up 1. This is going to be left 1. And this is going to be a reflection over the x-axis. And again, here's your parent function, right? Which means this is going to reflect over the x-axis, and then it's going to move left 1 and then back up 1. Okay, and then you just have to find out where that new picture is. And that's all you got to do. Flip it, do this one first. Okay, then do this one, and then do this one, and these are your steps. If you follow that, your picture is going to end up being the place that you want it to be at. Okay? Alright, so in page 3 of your notes, we're not going to worry about basis with fractions just because it gets a little nasty. And, again, all you're going to have to do is figure out the transformations off of something like this, and they're going to give you the picture. Okay? So if you look at this, what are my transformations? Okay? Well, we're going to have that right 5 move, which by their rules, that's what you're supposed to do first. And then here is going to be a vertical stretch of 4 with a reflection over the x-axis, and then down 7. And those are the things we want you to be able to do on your pictures. Okay? Now the last thing is something again you guys got to learn in Algebra 2, okay, is the value of E and whether or not you have something in base E. Okay? Base E is a number, remember it's a lot like pi, okay? But E is a number that has, and this number goes on forever and ever and ever and ever and ever, okay? With no repeats, just like pi, okay? But we do have an exponential version of that, which looks like this, okay? And if you want to look at those, and those are just some of the points, you don't get a calculator, so I would not expect you to do this. But we would expect you to be able to transform given the picture. So if you're given the parent function of this, and you look at this, all you have to do is move each of these, left 1. So you're just moving everything left 1, left 1, left 1, here, 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 and then you'd have this picture here, and that's all you have to do with your graph. And it's as simple as that. It's a pretty easy assignment. It's pretty short. So I think it's 8-9 problems max, and I think you'll be able to handle that pretty quick. Okay? So hope that helps you with 4.2.